So this worksheet, 15.3 Part A, you're adding and subtracting square roots. So you have all these radicals involved here, and all these radicals are square roots. Now when adding and subtracting radicals, you can only add and subtract like terms. And so when you're dealing with square roots and there's no variables involved, so notice no variable expressions, they're just real numbers, no variable expressions, it's pretty easy to determine whether they're like terms or not. So since there are no variables, notice no variable expressions at all, it's easy to determine when you can combine like terms, when they're like terms. So like terms would be this. See how this is the radicand here is 5, the radicand here is 2, and the radicand here is 2. It's just like if you had, like an example, if you had 5y plus 2x minus 7x. So remember, when combining like terms, I can combine the term x's because they're like terms. So this is raised to the first power, x to be raised to the first power, this is y. So this term is not a like term like these are. So I can combine these, so a positive 2, look at their coefficients, you add their coefficients. So a positive 2 and a negative 7 is a negative 5. So this becomes 5y minus 5x. Okay, the same idea applies here. So if you look at number 1, where you had 3 square root of y minus 7 square root of 2 plus 6 square root of 2, these are like terms because they're both square roots. The indices are the same, but in particular the radicands are the same as well. So just like we did this, you look at the coefficients, 2 and a negative 7, do the same thing here. What's a negative 7? So these two I can combine. What's a negative 7 and a positive 6? So a negative 7 square root of 2 and a positive 6 square root of 2 is a negative 1 square root of 2. So this becomes 3 square root of y minus square root of 2. Okay, so that's the answer. Now, you know, someone else could have said, well, I'm going to combine the square root of 2's and put that first. That's fine. So you would say this, so you would say negative square root of 2 plus 3 square root of 5, right? Now, guys, so make sure you understand that we prefer to write it like this. But if you wrote it as negative 1 square root of 2 plus 3 square root of 5, that's fine. But this right here is preferable, okay? All right, so that's number 1. So number 1, I'm going to write it as 3 square root of 5, 3 square root of 5 minus the square root of 2. All right. Now number 2, we have this. We have 3 square root of 48 minus 5 square root of 27. All right, now be a little bit careful. So you don't say, well, they're not like terms, so I can't do anything with them. You got to be careful. You got to remember that you need to simplify the radicals. Simplify the radicals. So you got to look at the square root of 48 and ask yourself, can I simplify this? So you must simplify radicals first. Okay, simplify the radicals. All right, so let's think about the square root of 48. Remember, you always use the largest perfect square. So what's the largest perfect square that goes into 48? All right, so you may say, well, what about 4? All right, let's check at 4. 4 is a perfect square. Let's see if what 48 divided by 4 is. 48 divided by 4 equals 12, right? So you know right away that 4 is not the largest, because think about 12. What perfect square goes into 12? 4 as well. So 4 times this 4 will give me 16. So 16 is the largest perfect square. So that becomes the square root of 16, and so 48 divided by 16. And notice the only perfect square that goes into 3 is 1. So right away you know it's 16. So that will be the square root of 16 times the square root of 3. And the square root of 16 is 4, so you get 4 square root of 3. All right, so that is just this now, okay? So look at what you have. You have 3 times, and this is now 4 square root of 3 minus, now let's talk about the square root of 27. So the square root of 27, was the largest perfect square that goes into 27. All right, so besides 1, it's 9, right? 9 is the largest. So that'll be the square root of 9 times the square root of 3. The square root of 9, 9 is a perfect square, so the square root of 9 is 3, so you get 3 square root of 3. So that goes here. So this becomes 5 times 3 square root of 3. So notice the steps. Don't do too much in your head without writing things down. You may mess up. So now 3 times 4 is 12, so I get 12 square root of 3 minus 15 square root of 3. And now notice those are like terms. So it's 12 square root of 3 subtract 15 square root of 3. Well, that's going to be a negative 3 square root of 3. So that's your answer, negative 3 square root of 3. So notice you have to simplify the radicals. You may say, well, why didn't you do that earlier in number 1? Because what's the largest what's the largest perfect square that goes into 5? Well, it's just 1. So I couldn't simplify any of these, right? Because the perfect square, the largest perfect square that goes into 2 is 1, and 1 as well, right? Okay. So keep that in mind. You got to look to see if you can simplify those radicals. So that was number 2. So the answer number 2 is going to be negative 3 square root of 3. All right, let's look at number 4. I'm sorry, number 3. So number 3, you have 3 square root of 12 minus 7 square root of 72 plus 5 square root of 50. All right. So again, don't say you can't simplify. Don't say you can't add or subtract these because they're not like terms. Well, first of all, you didn't simplify, so you got to simplify first. All right, so let's talk about the square root of 12. What's the largest perfect square that goes into 12? That's an easy one, 4. So it'll be the square root of 4 times square root of 3. And the square root of 4 is 2, so it becomes 2 square root of 3. You can't simplify that any further. So this right here becomes 3 times, and that's 2 square root of 3. Okay? Now let's look at the square root of 72. Square root of 72, what's the largest perfect square that goes into 72? All right, well, you may try 4. All right, try 4. 72 divided by 4 is 18. But is there a perfect square that goes into 18 besides 1? Yes, 9, right? 9. And what's 9 times 4? 36. So I'm going to write this as the square root of 36, and then 72 divided by 36 gives me 2. So that's the square root of 36 times the square root of 2. And the square root of 36 is 6, so the square root of 72 becomes 6 square root of 2. So I have this. I have minus 7 times 6 square root of 2. Okay? And let's look at the square root of 50. Square root of 50. So the square root of 50, I get the square root of 25. That's an easy one. So 25 times square root of 2. Square root of 25 is 5, so it becomes 5 square root of 2. So that becomes plus 5 times, and the square root of 50 is 5 square root of 2. All right, now, so I simplified the radicals. Now let's go ahead and simplify these products. 3 times 2 square root of 3 is 3 times 2 is 6. So that's 6 square root of 3. Minus 7 times 6 is 42 square root of 2. And then plus 5 times 5 square root of 2 is 25 square root of 2, right? Okay, now look at this. First of all, ask yourself, can I simplify this any further? No. Now, which of those are like terms? These, because those both have square root of 2's. Square root of 3, that's not like terms with these. So you got to look at this now. So you look at the coefficients and use your calculator if you need to. So I have a negative 42, right? So negative 42 plus, you're adding coefficients, plus 25 gives me negative 17. So what that means is that this becomes 6 square root of 3. These, when I combine them, becomes a negative 17, so minus 17 square root of 2. So that's your answer. Now, if you want to put the square root of 2 first, you can. You would have to say negative 17 square root of 2 plus 6 square root of 3. Does not matter. All right, so that was number 3. So the answer number 3 will be 6 square root of 3 minus 17 square root of 2. All right, now let's look at number 4. All right, number 4, we have negative 2 square root of 63. All right, so negative 2 square root of 63 plus 2 square root of 28 plus 3 square root of 7. Okay? All right, so negative 2 square root of 63 plus 2 square root of 28 plus 3 square root of 7. All right, now let's look at see if we can simplify these radicals. So let's look at the square root of 63. So think about the square root of 63. Is there a perfect square besides one that goes into 63? All right, well, let's check them. So the next perfect square after 1 is 4. Obviously, 4 is not going to go to 63 since 63 is not even. So let's go to the next one. The next one is 9. So let's see if 63 is divisible by 9. So 63 divided by 9 gives me, yes it is, 7. And can I simplify that any further? No, because what's the only perfect square that goes into 7? 1. So this becomes the square root of 9 times the square root of 7. And the square root of 9 is 3. So I get 3 square root of 7. So the square root of 63 simplifies to 3 square root of 7. So now this becomes negative 2 times the square root of 63 is this, okay? Plus, now let's look at the square root of 28. That's an easy one. What's the largest perfect square that goes into 28? 4. So we square root of 4 times square root of 7. The square root of 4 is 2. So I get 2 square root of 7. So this becomes 2 times, and then remember this is 2 square root of 7. And then, can I simplify the square root of 7? No, because the only perfect square that goes into 7 is 1. So that becomes plus 3 square root of 7. All right, let's rewrite this a little bit better. A negative 2 times 3 square root of 7 is a negative 6 square root of 7. 2 times 2 square root of 7 is a positive 4 square root of 7. And then plus 3 square root of 7. All right, so all these are like terms now because they all have square root of 7. So all you got to do is add their coefficients. So use your calculator if you need to. So you say negative 6 plus a positive 4 plus a positive 3 gives me 1. So the answer is just the square root of 7. Okay? Now, some of you are going to write it like this. We prefer this, all right? So don't write it like this. It kind of implies that you don't know that you can leave the 1 off. Because right here, that's understood to be a 1. So that's what we prefer. Okay, so write it like that. All right, so that's number 4. So number 4 is square root of 7. All right, now let's look at number 5. So number 5, we have negative 3 square root of 18 plus 3 square root of 8 minus the square root of 24. So negative 3 square root of 18 plus 3 square root of 8 minus square root of 24. All right, so we've got to simplify each radical. So let's look at the square root of 18 first. What's the largest perfect square that goes in 18? 9. So it'll be the square root of 9 times square root of 2. And the square root of 9 is 3, so I get 3 square root of 2. So this becomes negative 3 times, and remember the square root of 18 simplifies to this. So that's 3 square root of 2 plus, now let's look at the square root of 8. What's the largest perfect square that goes in 8? Those are easy. 4. So square root of 4 times square root of 2. Because 4 times 2 is 8, right? So the square root of 4 is 2, so you get 2 square root of 2. So that's 3, and the square root of 8 is this. So 3 times 2 square root of 2. All right, and let's look at the square root of 24. What's the largest perfect square that goes into 24? Okay, 4. So it'll be the square root of 4 times the square root of 6, right? The square root of 4, because 4 times 6 is 24. Square root of 4 is 2, so it'll be 2 square root of 6. So it becomes minus 2 square root of 6. All right, and let's rewrite this. So negative 3 times 3 square root of 2 is a negative 9 square root of 2. 3 times 2 square root of 2 is 6 square root of 2, and then minus 2 square root of 6. Now look at these three terms. Are any of them alike? Any of them like terms? Yes, these two. So I can combine those two. This is square root of 6, so I can combine this with these. So a negative 9 square root of 2 plus 6 square root of 2 is a negative 3 square root of 2 minus 2 square root of 6. And there's your answer. Now, if you want to put the square root of 6 first, you can. You would say negative 2 square root of 6 minus 3 square root of 2. All right? Okay, so that's the answer to number 5. So number 5, you have negative 3 square root of 2 minus 2 square root of 6. So in this on this worksheet, remember you had to first of all simplify the radicals and then combine like terms. All right, so that's the key to 15.3 part A.